Okay, so let's start. Okay, good morning, class. So again, um, welcome to our session. Okay, so we have a new topic now. So we have don't care conditions. Okay, so since you've all become pretty intelligent now, fast learner. Okay, so that's why we're able to get through. Okay, fast, just like a wind. Okay. So let's have the next topic, universal gates. Okay. So universal gates, so there are two gates that are actually fall under category of universal gates. So we have non-gates and NOR gate. Can you hear me, class? Can you hear me? Please say
Yes,
no
ma'am.
if okay. Okay. You may interrupt me anytime. Okay. So okay. If you have any questions, please feel free to ask. Okay. If you cannot hear me, please say so. Okay. So universal gates again. So there are two universal gates. So we have NAND gates and NOR gates. So NAND and NOR again can be classified as universal gates. Okay. So this one. Okay. So here are the equivalent of NAND gate. So if you have this configuration for NAND gate, so as you can see, if you have two input NAND gates, okay, so you just tie up the inputs together, okay, so it becomes equivalent to an inverter. Okay, so why so? So we have A, so if both inputs are A, so A times A is A, and then invert, so it becomes A prime. Okay, and then here's we have and okay, so we have none followed by an inverter. So this is equivalent of an inverter. Okay, so as you can see, this is the inverter. Okay, so this is a NAND. A times B invert and then another invert. So it's like AB open and close parentheses prime prime. Okay, so if you have double prime, what will happen again if you have double prime? Double negative, double prime. What will happen to prime?
Going back to original, ma'am.
Okay, so they just simply canceled out. Okay, so AB, open close parenthesis prime, and then another prime, so it will just be equal to AB. So you're just simply canceling out the prime or the negativity. Okay, and okay, so that's the equivalent of and. Okay, and then we have or. Okay, so or, so if you have inverters at the inputs and then followed by none. Why? Okay, so this is A prime. Okay, so again, this equivalent of an inverter. So take a look here. Okay, inverter. So this is A prime. This is B prime. So A prime, then it becomes input to none. So A prime times B prime. Okay, and then open close parentheses, then prime. Okay, so you apply the Morgan's principle here. So you want to put the prime inside the literal. So it becomes A double prime and B double prime. But you have to change the operator from times 2 plus. So we have, it becomes A plus B. Okay, A plus B is equivalent to 4. Question? Question? Question class with non-gates equivalent. So what I'm saying is, okay, what I'm saying is, okay, so if you want an inverter, so just simply draw this, okay, AND gate, so this is equivalent drawing or logic circuit diagram. And for OR gate, this is the equivalent circuit diagram for OR. So all you have to do is just to refer to this diagram, okay? Question. Question to NAND gates. Okay. Okay. Okay, so now question about NAND gates. Shall we proceed? Bakit naging plus yung last ma'am? Wala akong sound? No sound? Class? No sound?
Meron po ma'am sa amin eh.
Okay. Meron naman. Okay? So, error na. Meron sa iba. Okay. Bakit naging plus yung last ma'am? What? Alin doon, Justin? Ah, okay. Plus yung last. Plus. Using De Morgans. So, we use De Morgans here. Okay? So, for the last, okay. So, it's like, so I'll just discussing here. So, we have A prime times B prime and then prime. Okay? Okay, so I'm just retyping this one. Okay. Okay, so you have A prime, B prime, then you have an AND. Okay, so A prime times B prime. And then another invert, so we have invert. Okay, so this is the inversion. Okay, so using the Morgan's principle, so we're in, if you want to, if you want to distribute the prime here, so it becomes actually A double prime, B double prime. Okay, okay. A double prime and B double prime, but we have to change the operator. So it's obviously A prime times B prime. So A prime times B prime. So we have to change the dot to plus. Okay. So that's how it becomes. And then again, if you have double prime, so you just simply cancel the prime. Okay. Negative, negative, positive. So that's why it becomes A plus. Okay. Was I able to answer your question? Who asked that, Justin? Okay. So, okay, it's all right.
Ma'am, po ma'am.
Don't be embarrassed to ask question. Again, Ian?
Yun po dun sa pangalawa ma'am, parang ano po ma'am, kasi ma'am 'pag in-apply po 'di ba yung De Morgan's theorem?
Ungate. Ungate. This
Opo.
one.
Yung
Third.
dun po sa dalawang Nand
First,
Gates.
first is inverter. Second is and. Third is or. Which one are you referring to?
Yung pangalawa po ma'am, yung may dalawang Nand po.
Ah, this one. Okay. So this is an explanation for or. Okay. So let's have an explanation for. Okay. Okay. I'm glad you're asking questions. Okay. Okay. So for AND gate, okay. For AND gate, so we have this is an AND gate. Okay. So we have A times B. Okay. And then we have an inverter here, which is represented by a bubble. Okay. So we have prime. A times B prime. Okay. A times B open close parenthesis prime. And then we have another inverter here. This is an inverter. Okay. Okay. So we'll just have double prime. Okay. So again, we have A times B double prime. So if you have double prime, prime prime, so you just simply cancel it out. So that's why it's just simply equal to A times B. So this is the explanation for and.
Okey po. Thank you ma'am.
Okay? Ano difference nga dun sa pangalawa, ma'am? Bren, can you elaborate? Okay. Okay, so it's clear. Okay, okay. So it's nice to know that you're being enlightened. Okay, so let's now proceed with. Okay, let's proceed with what else? This is for Nand. Okay, let's proceed with Nor. Okay, with Nor gates. Okay, this is Nor. Okay, this is NOR. Okay, NOR. So for inverter, so we have this one, NOR. So A plus A is A, then invert. Okay, it's still A prime. Okay. So for B, okay, let's discuss this for, this is the combination for AND gate. Okay, so this is A prime, B prime. So it becomes an input and OR. So A prime plus B prime, then invert. Okay. So for AND gate, so we have A prime, prime plus b prime, and then, okay, a prime plus b prime, and then invert. Okay. Okay, so what principle shall we use here? Again.
De Morgan's po, ma'am.
Okay, so we'll use De Morgan's principle. Okay, we'll use De Morgan's principle, so it becomes A double prime, then B double prime, but we have to change the plus to, we have to change the operator from plus to multiplication. Okay, so we have A prime, A double prime, so again, if you have prime prime, okay, it's like negative negative, so we just simply cancels it out, so it becomes simply equal to a times b. Okay, and this is the actually and, okay, it's actually AND gate. Okay, ab. How about the equivalent for OR? Okay, so OR, equivalent for OR is NOR and then followed by another NOR. Okay, NOR configured as inverter, so again, so we have a plus b. Okay, and then invert a plus b, because this is actually an OR followed by an inverter, so we add it first, a plus b, then invert. Okay, and then followed by another inversion, because this is inverter. Okay, so we have a plus b, open close parenthesis, prime prime. So again, double negation, double prime, so you just simply cancel it out, so we have a plus b. So this is the explanation for OR. Any question?
None po, ma'am.
How about the others? I'll give you time to think. Okay, class. Okay. Okay, so while I'm doing my lecture, I am answering some queries. Okay, so I apologize for that. Okay, so let's proceed. Any question about Norgate? Norgate? Okay, none? Any question?
None po, ma'am.
Okay, so I hope everything's clear. Okay, so let's have an example for non-gate. Okay, so that means that, okay, that means that you can implement a circuit. Okay, so you can have a logic circuit using only just using only, where are we? We're lost. Okay, so that means that universal gates, you may implement a circuit using only either NAND or NOR. Okay, so you only need one IC. So that's what it means. Okay. Okay, so we're through. We don't care. Okay, let's copy this one. Okay, so let me see if we have this same. Okay. So take note that there's no equivalent for direct equivalent of XOR and XNOR in NAND and NOR. So only inverter and OR. Okay. So, okay. Okay, so we have an example here. Okay, so I implement the Boolean equation function of DCBA. So that means that we have four inputs DCBA, and the equation is BA plus B prime A prime plus DB plus D. Using AND or invert gates, then convert it to NAND, NAND only. Okay, so take note, we're going to use NAND only. Oh, okay, BA. So we have BA here, okay, connected to BA. Then B prime A prime. Okay, so we have inverters. Sorry for my drawing. It's not good. Okay, then we have DB. Okay, so we have DB. So use AND gate here and DA. Okay, then to tie those terms together, so we have BA is one term, second term, third term, and fourth. Okay. Then to tie them up, so you need an OR gate. So it becomes BA plus B prime A prime. And then DB plus DA. And then you have, okay. So we have here, okay, so this is our F. BA plus B prime A prime plus DB plus DA. Okay, so this is our initial drawing or logic circuit diagram for F is equal to BA plus B prime A prime plus DB plus DA. Okay, so let's convert it this one. Okay, so we have first and, okay, so we have BA. Let's copy. Okay. So we have BA. Okay, so we have BA here. Okay, so this equivalent of BA. Okay, so this is now your BA. Okay, this equivalent of AND. Okay, BA. Then second, AND gate. So this is B prime A prime. Okay, so we need a B prime A prime. Okay, so where is that? So we have to put it here. Where are you? Okay. Okay, B prime A prime. B prime A prime. Okay. But then, so this is equivalent of AND. Okay, so as you can see, you have NOR followed by another NOR. So that's the AND. Okay, but before that, you need to have a convert the inverter to NAND. Okay, so you have the inputs tied up together. Okay, so it becomes an inverter. Okay, so this is inverted B and A. Okay, BBA. Okay, so this input for B, so this is actually B prime. Okay, B prime and we have A prime. Okay, A prime, B prime. Okay, okay. Just copy the equivalence circuitry for AND or invert. Okay, so B prime, A prime. And then B prime times A prime. So this is AND. So the output is B prime, A prime. So what else? Okay, so we have DB and DA. DB and DA. So this is DB. Okay. Okay, this is DB. DB and DA. Okay. Okay. So we have DB, DA. So we convert the AND gate with its equivalence in NOR. Okay, DB and DA. Then next we have to convert this BA plus B prime A prime. Okay, BA. Okay, the OR, we have OR here. Okay, so that we can have an output BA plus B prime A prime. Okay, so BA is being inputted here and B prime A prime. Okay, so this is equivalent of OR in using NOR. Or using NOR. Okay, and we have another OR here. So we have DB plus DA. Okay, so what we are doing, we're just simply converting the AND or invert with its equivalent circuits in using NOR gates only. Okay, so we have DB plus DA. So this is the OR. So as you can see, we have DB, okay, input, another input DA. Okay, so the output of this one is dB plus dA. And then we have, okay, so we have, okay, last OR gate. So we have this OR gate here. Okay, so we have last OR gate here. Yeah, so we have, okay. 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 Okay, so this is just an initial conversion. Okay. Any question? Any question? May question po ako. Yes, you may proceed. Question. I'm checking now the chat. Universal gates. So, universal gates. Let's say, yeah. But we're not finished yet. Okay. So, universal gates, let's say, you want your circuit to be more flexible. Let's say you only want to implement the circuit using just NAND gates only. Okay, so it will give you flexibility. Okay, but we're not yet finished. Okay, so we're just an initial conversion. Okay, so we have this just an initial. Okay. And the next step is that when you see double inversion, okay, like this one, this equivalent of an inverter. This is also an inverter. So if you have two inverters in cascade, okay, one after another, so you just simply cancel them out. Okay, so we may cancel this. What else? Okay, so this one also. Okay, so you can easily spot the inverter if you see the inputs are being tied up. Okay, so this one cancel also. Okay, what else? Okay, this one and this one. Okay, so we actually have 1, 2, 3, 4, 5, 6, 7, 8 inverters. We can remove them already. Okay, so how? Okay, so we have the cancellations here. Okay, so inverter in cascade, so cancel. Actually, this one also. So I think I have overlooked this one. Okay, this one. Okay, inverter. Okay, so both inputs are tied up. Okay, what else? So we have this and this one and this one. Okay, cancellation of inverters in cascade. So when say again cascade, one after another. Magkasunod, no? Cascade. Okay, and then redraw the circuit. So how are we going to redraw that? So all you have to do is just to remove the canceled inverters. Okay, so how? So let's say we canceled it. So you just simply remove this. Okay. Okay. What happened? Wait. Okay. Okay. Uh, wait. Okay. Okay. So you just simply remove this. Okay. Also this one. Okay. Just simply remove the canceled and then you connect this, okay, with here. Okay, just like that. Okay, 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 that's what will happen. Okay, so likewise, so here, let's remove this. Okay, and this one also. Okay, and then connect this here. Okay. 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 And okay. Okay, I remove this one. Let's remove this. Okay, and this one. Okay. 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 So that's what will happen. Okay. And this will be the outcome. Okay. So as you can see, we have implemented the circuit using NAND gates only. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so you need 11 gates. So there are, how many gates in an IC from chapter 2? How many gates in an IC? Okay, so there are 4. Okay, thank you. Thank you, Justin. Okay, there are 4 gates in an IC. So you only need to buy three NAND gates. Okay, 3 NAND gates IC. So before it cost around 20 to 25. Okay, so to implement this circuit, so you only need to buy 3 NAND gates. Okay, whereas if you're going to implement this using the AND or invert, so you need AND inverter. So how many AND? So 3 AND gates. So one IC, 3 OR. So still one OR gate and one inverter. So still 3 gates. But here, if you only have NAND gates, okay, and you're already familiar with the pin diagram, so it will become easy for you to wire this, to implement the circuit. So again, it's just a matter of getting used to circuit. Okay, what else? So let's proceed with NOR gates. Okay, so let's have an example here. Okay, okay, so we have different example. Okay, so we have function of, oh, sorry about that. Question, class, question. Yes, 3 ICs. Okay. 3 integrated circuits. Okay. So take note that AND or NAND NOR are considered as quad IC, meaning four gates in a single IC packaging. Okay. Question. Question. Question, class. Okay, can we proceed with NOR? Can we proceed with NOR? Sample for NOR gates as a universal gates. Can we proceed, class?
Okay po, ma'am.
Okay. Okay. So, okay. D prime C plus DC prime plus B times A plus C plus D plus times C plus B. Okay, using AND or invert. Okay, same circuit. Okay, so we have D prime C. So this is D prime C. Okay, then we have Okay, D prime C. So you need to an inverter here. Okay. It doesn't want to move. Okay. Okay. D prime C. Okay. Then we have DC prime. Okay. DC prime. So you have an inverter for C. Okay. Do you have any problems with circuits, class, with how to how to draw the circuits, logic circuits? Okay. Ah. And then we have A plus C times B. So you have A plus C. Oh, what's this? A plus C times B. Mhm. Okay. So we have to. Okay, so we have yan, A plus C. Okay, so we use OR gate for A plus C and then times B. Okay, the input of A plus C is being inputted to an AND gate, then you have B input here. And then we have C plus B, okay, so OR gate, then times D, okay. So the output of C plus B is being inputted to AND gate, okay, and then D, okay. Okay, and then what else? So 2, then we have OR, okay, 1, 2, 3, okay, to put them all together, so to put the terms together, so we have ORs, okay, so we have D prime C plus DC prime. Okay, so the output of D prime C is being inputted to an OR and as well as DC prime. And then we have, okay, B times A plus C plus D times C plus B. Okay, so the output of B times A plus C and D times C plus B is being inputted to this OR gate. And then we have, okay, so we have this. Okay, we have this. Why do we have double equal sign? Okay. Okay. So this is the final OR gate. Okay. So what's next? So you have the initial circuitry. So what's next? What would be next, class? So we have initial circuitry. So next would be, what would be next? Aaron, what would be next? What do you think will be next? We have the initial circuitry. What would be next? Low?
Universal gate application po, ma'am.
Okay, so conversion. Okay, so we need to convert each gates into its equivalence in NOR gate. So we have equivalence. Okay, so we have to convert inverter into this one. Okay, so we have NOR in which the inputs are being tied up. So if you have the inputs being tied up, so it is an inverter. For AND, so you have inverter at the inputs. Okay. NOR configured as inverter at the inputs, and then another NOR. Okay, and then for OR you have series NOR in cascades. Okay, NOR and then followed by another NOR configured as an inverter. Okay, so we have again we have to convert the inverter to this and to this. So you have 3 NOR gates and or you have double NOR gates. Okay, so let's see. Okay, it's already being prepared here. Okay, so we have, let's copy. Let's copy. So we have D prime C and DC prime. Okay, so you have D prime C. Okay, D prime C and DC prime. So At first glance, it's tedious, but if you only have one IC configuration to memorize, so it becomes easier. Okay, so we have D prime C and DC prime here, right? Then we have okay, A plus C and C plus B. Okay, so we have C and C plus B. Where are you? So you have A plus C here, A plus C, and okay, plus B. Okay. Uh, C plus B. Okay. And then we have what else? So we have okay, B times A plus C. Where is it? Here. Okay. This is some kind of A plus C. B times A plus C. Okay, we have and we have what else? D. Okay, we have D times C plus B. Okay, we have and then or. Okay, so after the or, so you have okay. So this is equal to D prime C plus DC prime. Okay, DC prime. And then we have okay, this or. Okay. Okay. What else? And then finally, so we have okay, equivalent of or. Okay, so we have F is equal to this. Okay. 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 F is equal to D prime C plus DC prime plus B times A plus C plus D times C plus B. Okay. So what we did is was we just simply convert the inverter to its equivalence in NOR, okay, and to its equivalence in NOR and or to its equivalence in NOR. Question class. Can you follow? Donald, can you follow? J Lord, can you follow? You may answer yes or no. Any question? Can you follow? Marian? Hello?
Yes
Okay.
po, ma'am.
Justin can follow. Ian can follow. How about the others? Can you follow? Can you follow? Ma'am, pwedeng patingin ng buong circuit. Okay. Yan. Ba? It's nice to ask questions. So, okay. So, this is the, okay. So, we only converted the inverter to its equivalence in NOR and to its equivalence in NOR and or to its equivalence in NOR. So we just simply replace it with its equivalence. So after this, after converting the inverter and or to its equivalence in NOR, so what would be next? What would be next? Class. What's next? What would be next?
Cancellation po, ma'am.
Okay, so we will cancel if you have double inverters in cascade or one after another. Okay, magkasunod na inverters, so we will cancel that. Okay, negative, negative, cancel. Okay, so just this one. Okay, so if you notice, so you have this one. This is inverter and another inverter. Okay, saan pa? Okay, this one also. Okay. And this one, okay. What else? This one, okay. Okay, so let's try. Okay, let's cancel. Okay, double inverter. So again, so if you see double inversion, okay, canceled. Okay, okay. So what else? So we have this one. Okay, okay. What else? Ito. Okay. Ito pa. Okay. Huh? Okay. Okay. So we have here and here. Okay, meron pa ba? Double inverter? None, no? Okay. This one. Okay, so we're able to cancel out six inverters. Okay. And then let's see. Okay. Ito na yun. Okay. So these are the canceled out inverters. So what you will do is to remove this. Okay, so we'll remove. Okay, remove the double inverters, and then okay, connect this. Okay, so yeah. Okay, ano pa? Okay, this one. We remove this one. Okay, and then this. Okay, connect. Okay. Okay, and then we have, okay, where else? So, okay, okay, okay. So it will be like that. So we remove the canceled inverters. Okay. Okay. And then, Okay. Question? Panoorin ko na lang ulit sa YT, ma'am. Medyo putol-putol kasi boses naman pag nawawala connection ng data. Okay. Cancel, ma'am, di ba? Double inversion, cancel. Double inverter, cancel. Okay. Negative, negative, positive. Okay. Question. Question? Okay. Then, let's continue. Okay. Let's continue. Okay. Let's see. Okay. So here is now with the inverters removed. Okay. So as you can see, we just simply remove the inverters and then connect the line. Okay. So we form it's like a bypass line. Okay. So what's left is, so how many gates? There are originally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 if my counting is right. So from 24 gates down to 2, 4, 6, 8, 10, 12, 14, 16. So we're left with 16. Okay, so 16 gates. How many IC would this be? You need to buy. So again, you have quad gates. So you need to buy how many IC? Okay, so 4 ICs, no? Okay, 4 ICs. Okay. Question. Okay, so you have an assignment. I've already given assignment. Okay, you have assignment here, but the assignment, this one will be due next week. Okay, next week. Okay. Assignment. Okay, so let's have an assignment here. Let me see. Let me check. Okay. Okay, just answer this assessment number 3.4. Okay? Only one. Only number one. Okay? Assignment for universal gates, please answer assessment number 3.4, one only. Okay? Question. Question, class, question. Okay, let's have an attendance. Aaron. Aaron.
Present, ma'am.
Okay. Bren, wala. Okay, so no mic. Donald. You have a microphone, Donald. Ian. Okay. Jennifer. Jennifer.
Present, ma'am.
Okay, you're okay. Okay, Ruben, no mic. J Lord. Okay, present also, no mic. Okay, Justin, Marian. Marian.
Present, ma'am.
Okay, and Ruben Del Valle. Okay, no mic. Okay. So thank you for attending my class this morning. Okay. I hope you're stay safe. Okay. So there are more people who are being tested positive for COVID. Even Bitoy is tested positive in COVID. Okay. So stay safe. Okay. So I hope everything's fine with you. Okay. So if you have no more question, class, no more question. No more question? Hello? No more question? Okay, so if you have no more questions, so bye.